Alright guys, so in the last video we talked about how to name ionic compounds if you're given a formula. Today we are going to try and do the reverse. Okay, we're going to, if given the name of an ionic compound, try to come up with its formula. Okay, so to write the formula of an ionic compound, we first have to figure out the formulas and charges for each ion, okay, and then we're going to do what I like to call the crisscross. And really this is kind of a way to cheat, but I'm going to talk about the function and why it works also. Oops. Okay, so what do I mean when I say crisscross? Okay, so it is a method to make sure, which is always true, okay, your total charge is 0. Okay, so 0. So you cannot have an ionic compound that has an overall charge. Okay, the charge of the positive ions has to exactly cancel out the charge of the negative ions. Okay, so taking the charge of one ion and making it the subscript of the opposite ion. Remember, the subscript are those little letters, like that little guy that says how many you have. Okay, so a couple tricks here is ignore negatives when moving numbers. Okay, so you know, for like this example here, oxygen has a -2 charge. When I crisscross and I bring the 2 down here, I don't have -2 aluminums. That doesn't make any sense, right? You just say how many there are. You can't have a negative number of something. Okay, so ignore negatives and reduce subscripts if you get numbers that aren't their lowest ratio. Reduce, I mean like in math. Okay, so like if I crisscross and I get Mg2O2, I have 2 magnesiums and 2 oxygen. Is that their lowest ratio? No, that would reduce down to just 1 of each, which we would just write MgO, right? Okay, so we have to also have one more little thing here. If one of the ions is polyatomic, which remember from our last lecture, were these guys, okay, ions that are made of more than one element kind of stuck together and they just stay together. Okay, so if one of your ions is a polyatomic, we put parentheses around the ion before we put the subscript that says how many you have. Okay, and I'll talk about why that parentheses is important. But let's kind of look at this example here. So if the question says, you know, write the formula of the equation or of the chemical that would form when aluminum and oxygen form an ionic compound. Okay, so I have aluminum here and oxygen here, and I need to know, well, where did these numbers come from, first of all? Okay, so we have to remember our kind of cheat here. Okay, to predict the charge of the ions, these guys would be 1, these guys would be 2, and then we skip over the transition metals, and these guys would be 3. And then remember, noble gases don't really do anything, so they would be 0, but then we kind of go backwards. So these would be -1, these would be -2, these would be -3. So aluminum is in the column that would be +3, and oxygen is in the column that would be -2. Remember, that's based on how many electrons they would have to gain or lose to have the same number as a noble gas. Okay, so aluminum has a +3 charge, oxygen has a -2 charge. Okay, so we need 3s and 2s, I guess I should say, somehow to add up to 0. Okay, and this is the same example from the Tyler DeWitt video I had you guys do yesterday. Is the idea is, you know, if I have only these things to work with, right, and I need to add up to the same number absolute value wise in this column, okay, So I can kind of think, okay, what's the least common multiple of 3s and 2s? Or I can think, okay, well, this is bigger, a 3 is bigger than a 2, so I know I need one more of these. So now this adds up to -4, and this is only +3, so I'm like, well, I guess I'm going to need one more of these. And then that's +6, and you're like, okay, well, if I have one more of these, oops, that's a 2, then I have -6 and +6, and that would add up to 0. Okay, so this is kind of just a cheat to make that happen, if you do this crisscross. So you take the charge of one element, the 2, and make it the subscript of the opposite element, the aluminum. Take the charge of this aluminum, which is 3, and make it the subscript, the how many of the oxygen. Okay, so those charges still exist, but we don't usually write them out in the equation. So here's just a little practice here. Okay, and if you don't have a periodic table or you don't use ptable.com, you're going to be lost, right? So you need to know how to use that periodic table to predict charges. There's a reason we had a whole chapter about that. Okay, so it says write formulas for the following. Lithium oxide. Okay, so I find lithium in the periodic table. It's in this group, which tells me when it's in an ionic compound, it will have a +1 charge. So what I like to do is just kind of write it above. Okay, so that's +1. Oxide, remember, it's just the name of oxygen, and all these nonmetals, their names change to "ide" when they're negative. So oxide would be 1, 2 negative, because it would gain 2 electrons to be like neon. So -2. Okay, so then I'm going to write their symbols, lithium and oxygen, and do the crisscross. Right, so lithium's charge is 1, so I would make 1 the subscript here, but you don't remember, if you don't write anything, that's the 1. And then here's a 2. Yes, I realize it's -2, but we ignore the 2's when we crisscross. So I have Li2O, which means I would have 2 lithiums and 1 oxygen. Okay, charge-wise, let's see if this makes sense. So lithium's +1, oxygen's -2. If I have 2 lithiums, I have +2 and -2. Those cancel out, so that's perfect. All right, second one, magnesium nitrate. All right, so here is magnesium. It is in group 2, so it will have a +2 charge. Okay, and then it says nitrate. Okay, so if it was a plain non-metal ion, it would end how? If it was a plain ion monoatomic, it would end in "ide." But it doesn't end in "ide." That ATE ending is kind of a red flag that we've got one of these polyatomic guys. Okay, so nitrate is NO3 with a -1 charge. Okay, so I'm just going to write the -1 here for right now. And so remember, the charge of 1 tells you how many you need of the other. Okay, so nitrate has a 1 there, so that means I just need 1 magnesium. And magnesium has a 2, which means I need 2 nitrates. So here's my formula for nitrate, NO3. Okay, so up above when I said if one of your ions is polyatomic, we need to use parentheses. Okay, so I need 2 nitrates. Okay, so if I just put the 2 right here without any parentheses, what is the problem here? Okay, it looks like I have 32 oxygens. I don't want 32 oxygens. I want to say 2 nitrates. So that's the purpose of those parentheses, is to say, kind of separate these. Okay, and say this whole thing here, I have 2 of them. This is the nitrate ion. I have 2 of them. Okay, all right, let's try another one of those. Okay, sodium is in group 1. So its charge is +1. Carbon 8, there's that ATE ending again, which is kind of your red flag that you've got a polyatomic ion here. It is CO3 with a -2 charge. So carbonate is -2. Okay, so that means, remember this 2 means I need 2 sodiums. So I have, there's my formula for sodium, and I have 2 of them. And this 1 means I just need 1 carbonate, so I have CO3. Okay, so a lot of times people want to leave that 3 off of there because they're like, well, I only need 1. That 3 is part of what carbonate is. Okay, these subscripts are part of the ion, so that 3 is part of 1 carbonate ion. Okay, if I was going to have 3 carbonates, I would put this in parentheses and put a 3 out here. Okay, but I only need 1. Alright, 3 more here. Okay, we have ammonium sulfate. This is not an element. You're like, I've never heard of the element ammonium. That's our one kind of weird one. Okay, it's NH4 with a positive 1 charge. So I'm just going to put +1 here. And sulfate, that ATE is another kind of clue, is SO4 with a -2. -2. Okay, so remember when we crisscross, this 2 means I need 2 ammoniums. So I write the formula for ammonium, NH4, and to show that I need 2 of them, I put it in parentheses and put a 2 here. Because I don't want 42 hydrogens, I want 2 ammoniums. Okay, and this 1 means I just need 1 sulfate, so I write SO4, that's the formula for sulfate. Okay, I don't need any parentheses for this one, because I don't need to put any subscripts out here. I don't need more than 1 sulfate. Alright, iron 3 iodide. Okay, so this Roman numeral here is there, remember, because it's a transition metal. Transition metals, we have to put the charge in parentheses after. So I know, even I don't have to go to the periodic table, this iron's +3. That's what that 3 is telling me is the charge of iron. And then it's have iodide. Okay, so I grab my periodic table. I got to figure out what would be the charge on iodine. Okay, it's right here. It's 1 away from being like a noble gas, so it's going to be -1. It's going to gain 1 electron to have the same number as xenon. Okay, so then we crisscross. So iron is Fe. Okay, always use your periodic table if you're not sure of symbols. And how many do I need? Well, I look at the charge of the opposite one. It's a 1, so I just need 1. But remember, we don't write a 1. And then we have iodide. And to know how many, I look over here. There's a 3, so I must need 3 of them. So again, let's kind of check in on our charges here. Okay, so if the iron is +3, and iodine is -1, I'm saying I need 3 of them. -1, -1, -1. That's perfect. +3 and -3 cancels out. Okay, so we're doing something right. Okay, last example. Chromium, remember that's 4, so that's telling me the chromium is +4. And then we have that ATE ending instead of "ide." Remember, "ide" are plain elements. ATE are always these guys. So we have sulfate, which is SO4 with a -2 charge. -2. Alright, so let's see what we got here. So chromium is Cr. How many would we need using the crisscross method? Alright, so remember, to figure out how many we need, we look at the charge of the other ion, so that'd be a 2. And sulfate is SO4. And how many would we need? I'd need 4 of them. Okay. Remember, the parentheses are because I don't want 44 oxygens and I want 4 sulfates. So what is the matter with this equation the way we have it written right here? Okay, so this is one thing that I'm glad we have one example of. We always want to reduce our subscripts. Okay, so right now we have 2 of this one and 4 of this one. Is 2/4 a good way to write a fraction or a ratio? No, we would want to reduce that. Okay, so 2 and 4 are both divisible by 2. So instead we're going to write CR, imaginary 1 or nothing, SO4, and I would need 2 of them. And maybe a clue so you remember, why did we do that? Oh yeah, we want to reduce. Okay, we do not change that 4. Remember, that 4 is part of sulfate's identity. Okay, you cannot get rid of that 4. That is what sulfate is. Alright. We have... Do I want to do this? I don't think I do. So we're just going to focus on ionic compounds here, okay? Which means, for our purposes, we can get rid of the right half of both of these flowcharts. Okay, so when you go to name, here's our rules, okay? Positive ion name followed by negative ion name, and here's kind of our special rules here, right? So transition metals, we show the charge in Roman numerals. Polyatomic ion names do not change. Remember, a lot of them end in 8. That's kind of a clue that you've got a polyatomic ion. And if it's a monatomic, the last element is going to be "-ide". And then we go to write formulas, figure out the formula and charge, and then we crisscross. Reduce if you have to. Use parentheses for polyatomic ions. Okay. I'm getting rid of the molecule naming and stuff just because we're not going to have time and I have other stuff that is taking priority. So as always, ask questions if you have them, and good luck.